Hi, this is Math 1428, and we're continuing the discussion of section 8.2 on arithmetic sequences and series, and you can call this video 8b. We're now prepared to talk about the sum of the first n terms of an arithmetic sequence. So let's start with this arithmetic sequence. Again, the initial element is 3, and we're adding 2 each time, so the difference is 2. But now what we're doing is we're adding these together, and this would be what we're going to call S4, the sum of the first 4 terms, and if you added those together you would get 24. This sum is called an arithmetic series meaning we add them together. And to find a formula for these things, we're getting a formula for Sn. We start and we say, well, we're going to be taking A1 and we're adding it to A1 plus D, and this is A1 plus 2D, and keeps going. This is AN minus 2D, and this is AN minus D, and this is AN. And so Sn then is given by, we add those things together, and we rearrange items. And when we rearrange items, what happens is we are writing them a different way. And so when we add them, what happens is many of these things cancel out. I'm not holding you responsible for the proof, but that is what happens. So 2s sub n is all of these things, but you see this simplifies, so 2s sub n really is equal to a whole bunch of sums that are all a1 plus an. And so the formula that we get, and this is the important thing to remember, is that Sn is equal to n over 2 times the whole of a1 plus an. Let's exercise this formula a bit. Find the sum of the first 100 natural numbers. So that means we want to add up 1, 2, 3, all the way up to 100. Well, the first term is 1, the last term is 100, and n is 100, so Sn is 100 over 2, 1 plus 100. You do the arithmetic, you get 50/50. Here's an example that you can try to test your understanding. Here's another, perhaps more complicated example. Find the sum of the first 15 terms of the arithmetic sequence 4, 7, 10, and 13. Now here we can note that the first term is 4, the difference is 3, and n is 15, and so the thing that we don't know now is Sn, and so what we're going to do is we're going to solve that. We'll plug in all the numbers, and we get 46 is what A15 is. You see, we didn't know A15 to use that formula. But then S15 is going to be 15 over 2 times 4 plus the 46 we had here. We get 375. So the sum of the first 15 terms is 375. Here's an example that you can try to test your understanding. We are not going to have to know about the summation notation, but what this is talking about is you go 9 plus 13 plus 17 plus ... and you go all the way up for 130 times. So again, we have to figure out what A130 is, and we use this formula, and we get that A130 is 525. So the first term was 9. The last term is 525. We were doing 130, and so we do the calculation. This is what we get. Here is an example that you can try to test your understanding. There also are always word problems because life is a word problem. Here Kendall accepts a job starting at an hourly wage of $14.25, and he's promised a raise of 15 cents per hour every 2 months for 5 years. At the end of 5 years, how much will he be making? Well, you see what happens is he gets a raise every 2 months, and so this is going to be a arithmetic series. So he begins here, after 2 months he gets this, after 4 months he gets this, and so on. So this is a sequence of numbers. Each one is adding 0.15 to the last. So what we want to know is, what's the last term? How much is he making at the end? Well, that is An is equal to A1 plus n minus 1 times D. And we have to know what n is, and n is going to be, let's see, it was 5 years, so there will be 31 terms when we subtract 1 from that. And so A31 is going to be 14.25, 31 minus 1 times 15, and that's going to add up to be this. That's his salary at the end. Here's an example that you can use to test your understanding. Here we're stacking some things, and we got 30 poles in the first row, 29 in the second, 28 in the third, and we get 5 poles in the 26th row. So you see what we want to do is add these numbers together. Now it's important to realize then that this is an arithmetic sequence. You start here and you go down, but D then is minus 1. So we're going to use this formula, and we have to talk about how many terms we have. So going from here to here is going to be 26 terms. So N is 26 divided by 2. The first term is 30. The last term is 5. So S26 is 455 poles in the stack. And this is an example that you can use to test your understanding. By way of closing, along the way we noted exercises to test your understanding. These are aligned with specific examples illustrating the concept. So an engaged student, if their circumstances permit, should try these. And remember, we're not doing the summation notation. A passionate student with sufficient time might try to do even more. Now, more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now, more than ever, take care of yourself and of each other. God bless. See you.